How do you foresee the evolution of AI tools and platforms in the next 5 to 10 years?
Don't underestimate the value of open source. Open source will change your life for better.
Welcome to the AI Product Engineer Show, where today we have the pleasure of speaking with Andrey, founder and CEO of dstack. Andrey is a seasoned tech entrepreneur with over a decade of experience at JetBrains, where he led product management and marketing for their flagship IDEs. dstack is an open source platform that simplifies the management of AI infrastructure across any cloud environment. It empowers data scientists and developers to orchestrate GPU workloads for model development, training, and deployment. In this episode, we'll dive deep into Andrey's journey and inspiration behind dstack. Stay tuned for an insightful discussion that explores the challenges and opportunities in the field of AI infrastructure. Without further ado, let's welcome Andrey to the show. Tell us a fun fact or story about yourself that most people don't know.
Thanks, Rod. It's a great question. Many people know that I like food, and you can call me a foodie. And also many people know that I travel a lot. However, I think not many know that I sometimes travel just for food. When I say to people that I travel to Hong Kong twice just to eat dumplings, actually, yeah, it sounds really crazy.
And what aha moment led you to start your company?
Now that you ask me, there were a couple of moments. Before dstack, I was working with JetBrains, and basically building development tools is kind of a thing I really like. And as a PM of PyCharm there, I was involved in many interviews with ML teams, and this is something like special that I noticed many times, is that ML engineers really struggle when it comes to infrastructure. Because ML engineers love to spend time with models, with code, and infrastructure management is more where ops people actually are more confident with. So that's why many ML teams people actually struggled a lot, because they had to manage some kind of the infrastructure and to deal with that, even though they main passion light with ML. And it could lead to people manually managing infra and having to learn how to do it, up to even more serious stuff. Like I remember I talked to actually people at JetBrains, and we discussed what can we do in order to train more models. And one thing that really made me think was, people from the team said, we actually have some hardware and we use it as much as we can. However, we cannot, buy like a lot of hardware because there are much fixed costs. At the same time, it's really difficult to use cloud because of the costs implied. So basically, the situation is when you can't buy a lot of hardware. At the same time, you cannot invest a lot in the cloud infrastructure because you're afraid of a lot of costs. And what it leads to is that your team doesn't do what it's supposed to do. Basically, instead of doing many projects, you do very little. And that was exactly when I thought we should do something about it.
How would you describe your startup to someone who has never heard of it?
Well, we built dstack for ML folks, and if somebody who is doing ML would ask, okay, so what do you do? I would tell the following: look, as an ML person, you need infra in order to do development, to train models, to fine-tune models, and to deploy those models. And there are quite a few vendors that actually offers that tools, but most of the tools are either proprietary, means that you have to use the user interface and you have to basically follow that vendor's way, and basically you have to invest a lot into learning how this particular vendor works. So basically you learn how this vendor offers you to do that. Compare this experience to using open tools or using open source tools. For example, compared to, like, for example, tools like Docker or Terraform, those are tools that are open. They are basically standards. It doesn't really matter what vendor you use, like be it AWS or Azure or GCP. You learn how Docker works and you really understand the fundamentals of the containers. So it doesn't really matter how any particular vendor works. All you need to learn as a developer or as an ML engineer, like for example, Docker. So that's something that we built at dstack. We built an open standard for managing AI workloads, like for development, training, and deployment. Somebody can also think of this as a replacement for Kubernetes if Kubernetes was built for ML engineers.
Why is this stack so pivotal for those building in AI?
One reason is because dstack is an open standard and it works across vendors, it makes it much easier to switch between vendors or not to depend on a particular vendor. And today, there is a very big GPU shortage, and getting on-demand, spot, or even reserved instances to basically develop your models, train your models, or deploy them, it's not an easy thing. And only companies that actually have quite a lot of resources can afford that. So with dstack, we let ML teams not think much of their vendor and be able to switch between vendors and actually use multiple vendors at the same time. So that's one aspect. And I talked to many people that actually use dstack specifically to get this on-demand and spot instances because it helps them use GPU without heavy investments.
Can you share one story where this stack significantly helped one of your users?
There were quite many times when I talked to their dstack users, and what I learned is that pretty often when you need cloud GPU on demand or spot, what you have to do is basically either use multiple vendors and basically you look for capacity across multiple vendors, or even write custom scripts that actually try to request this GPU on demand. And well, it's most of the time it's not available because there's so much demand. So the script would basically try to ping it every other 5 minutes to see if there's an available GPU. And once it is available, they basically book it, and then you can, well, the same day or next day start developing. Also, I've seen many teams that actually use multiple providers, and they have custom code in the project that this code runs this, I don't know, on runpod. This code runs it on TensorDoc, or another code runs it on AWS. It's like I wouldn't believe that, but that happens a lot. And when I told one of the users that, well, with dstack you don't really need to write that code. It's basically what dstack is. It lets you book GPU or run stuff on GPU with either any vendor of your choice or with multiple vendors. And yeah, that was a game changer, I guess.
Can you walk us through a typical use case, a scenario of this stack?
There are four major scenarios, and most of the time people switch between them when they use this stack or actually are involved in a ML project. One, let's say, starting use case is getting GPU. And with this stack, it is possible to get GPU from either a vendor of your choice or from multiple vendors. And for example, we have such a thing called dstack pool. Pool is an abstraction that lets you book capacity in a particular vendor or multiple vendors. And you can say, okay, I need like, let's say, several instances with that GPU, for example, characteristics, and this stack can actually reserve them. Well, not exactly reserve, but basically get them, for example, as on demand. Or it's up to you to say whether you want to have these instances like spot or on demand. And once dstack got them, they remain in the pool, and you can use them for any kind of things that you want. So regardless of the vendor. Second, often what our users do is development. Before you can, let's say, run a long running job like fine tuning something or deploying something, you often may want to experiment with the model. And what we learned is that the best way to experiment with the model is not even by, let's say, chatting with the model, but especially for ML teams, but rather running a dev environment where you can run Jupyter notebooks, Python scripts, whatever. It's just, let's say, for example, you can use either PyCharm or VS Code, and this tech lets you basically run a dev environment with a capacity, with an instance that matched your requirements. And this is super cool, especially when you want to experiment, see what like how model behaves itself, and experiment a lot. Then, for example, now that you know what you want to do, let's say you want to either fine-tune model, like, or deploy it, you can use two other things that this tech offers. And first thing there is tasks. We call them tasks. You can define a task, be it fine-tuning or training, and then you can run that task, and you just can tell what requirements that task has in terms of the infrastructure. And then this task uses the infrastructure from the pool, or will request it on demand. And finally, there is a thing that we call services. Service is something that you want to deploy, and we guarantee that this deployment is available as a public endpoint. And this tech handles about the authorization, many other things. But basically, once you want to deploy a particular model, you define a service, and this tech takes care of deployment that, regardless of which provider you use.
For those who are starting building AI products, working with AI, what do you recommend to them?
Based on my experience, and also reflecting through my experience, what I would often say is don't fall in love with a particular vendor. Fall in love with their best practice or with specific tool that you can reuse across vendors. And I'm not saying that only because, well, this tech helps to do that, but I'm a big fan of open source tools in general. And imagine, let's say, OpenAI today is their number one company when it comes to AI, and it shows the way. And I have huge respect for what they do. At the same time, for example, if you look, OpenAI the product of OpenAI evolves pretty quickly. They introduce many stuff. They do a lot of experimentation at all. And people actually sometimes think it's really hard to keep up because, well, there are many new things every day. And it's true, they are. However, if you look at the best practices and at their, let's say, tools that over time get more mature, like you realize that, well, vendors come and go, and there are new vendors join the party. Well, best practices and like open source tools, they are here to stay. That's why I would rather recommend following their, learning more about these best practices, like retrieval augmented generation, like structured data extraction, like different ways of using open source models and using Docker to deploy generative models and things like that.
How does dstack help beginners in AI?
Again, when we talk about AI today, there is slight confusion because some people still think about AI as machine learning, and some think of AI as something like magic that is available when you invoke certain endpoint, most likely OpenAI endpoint, which is not the way to say that it's not ML or it's not AI. It is, but when, for example, I refer to AI, I mainly and most often refer to it as something that you develop. And most likely you are using open models or custom models. That's why um, it is most of the time is about machine learning. So this stack, because it's vendor agnostic, it doesn't really matter which model you use. You can use any open model out there. You can grab any model from Hugging Face. It doesn't matter which serving framework or fine-tuning framework you use. Anything that you find on GitHub or Hacker News another day, you can use with dstack. So that's what I think is most profound about dstack, that it doesn't really depend on any particular vendor, on any particular way you train or deploy your models. What we try our best at the team is make it work in any scenario. It doesn't matter what model or what tool you use. While dstack actually helps with the infra.
How do you foresee the evolution of AI tools and platforms in the next 5 to 10 years?
It is really hard to make any predictions, not actually because it's hard to predict something. It's very easy to predict something, especially when it's a wrong prediction. But for me, it is hard to stay kind of realistic about that. We see that AI is evolving with so much speed, and it is a surprise to even most optimistic predictions. Well, I would certainly see a lot of commoditization happening in the area of, let's say, generative models. We're going to see a lot more competitors to OpenAI, and of course, we're going to see that how OpenAI is pushing the boundaries of what is possible even further. At the same time, we'll see how many more companies will join to offer common models, like generic models that generate text, that generate video, that generate audio and images. So basically, it's all about generative models, and it's all about doing it even better and better. And we're going to see a lot of vendors to come up. At the same time, of course, we already see that companies do open source models. And I strongly believe that this trend will stay. We're going to see more and more models. And even though some people are skeptical about that, like, for example, we see that some companies open source a model just as a marketing way. Like they typically have a commercial one as well, and they open source a smaller model to attract users' interest, and of course to increase their brand awareness and drive their user base as well. However, it's still very good for the market because we see more and more models appearing and like for everyone, so everyone can use them commercially. So I strongly believe that there'll be more and more models, and those open source models that are released, they'll be even stronger and stronger and come close to the quality of proprietary models.
Which top 3 tips can you give to fellow AI engineers?
I suppose those tips wouldn't be very much different if I gave them to developers or to some other technical people. It's not only about AI folks. One general advice I give is learn fundamentals. Often people think there's a new thing. I need to learn how these things works and how I need to learn how to adopt it, how to build something with it. And yeah, this is very natural and this is very cool. However, it is very important that you understand the fundamentals behind it. Why? Because things come and go and they change, but fundamentals, they are fundamentals. And when you know them, it's so much easier to build on top of them. So that's why I would typically recommend people to have some solid understanding about the fundamentals. It helps very often, and if there's a new thing, it helps you. It makes it much easier for you to learn how it works and build on top of that. So that's I guess one thing. Second, again, very generic piece of advice is people often tend to think, I need to learn, so I'll go and check some theory. Theory is good, but well, there is also practice. So most of the time, I would push people to go and do something, because when you do something, you understand, well, what you learned, the theory part, well, often you see that it didn't work or didn't match. So it pushes you even further to understand how this works. And until you actually go and try to build something real, I mean, not a pet one, not a pet project, but a real one, it's unlikely that you'll really learn a lot.
As a wrap up, what's one message that you'd like our listeners to take away from this conversation?
I would say don't underestimate the value of open source. It's very easy to do, but I would encourage you to have more faith in open source. And I think that's important, especially now in the era of AI. So open source will change your life for better.
Fantastic. Thank you so much, Andrey.
Thank you, Rod.